I'm going to cover several techniques that can help improve the look of your procedural terrain. Specifically, we'll talk about more advanced blending techniques, triplanar mapping, splatting, and texture repetition. We're continuing the series on 3D world generation in this project and talking a bit about texturing strategies. There's a reason that big AAA games go to real lengths to get their terrain looking good. It's a complex subject, and there's a lot of ways to do this. We previously covered quad trees and planetary level of detail, but up until this point we've sort of skirted the issue of textures and shaders on the terrain in favor of mesh generation. What I'm going to do today is cover a few different approaches to terrain texturing, a sort of mix and match of techniques that you can be familiar with, and you can decide whether or not they're right for your project. So those techniques are triplanar mapping, texture splatting, height-based blending, and texture repetition. And what I'm going to do is go over each of these in a bit of detail. Remember that the code is all available as well. If you need to reference it, feel free. Let's start with triplanar mapping. So let's look at what this technique is trying to fix. We've got some simple rolling hills, and we choose the UVs based on the XY coordinates. So once I add a texture, it all looks textured. Now, if I were to sharply increase the height of the terrain, say for a cliff face or something like that, notice what happens. You've got this ugly stretching right here on the cliff face, and that's because we're essentially projecting a texture down from above. And this is exactly the problem we're looking to solve. We want that texture to be applied appropriately from every angle, not just above. This is where triplanar mapping comes in. The idea behind it is really simple. Sample the texture 3 times, once along each axis, and then project it onto your geometry along that axis and just kind of blend based on which way it's facing. Going back to this piece of the landscape now, if you were to sample the texture now, not just from above, but from each side, and then blend them all together, this would look a lot better. Let's take a quick look at the shader code that makes this happen. What I do here is I use the world space position of each fragment, and then we take the normal here and use this as the weighting for each texture sample. One thing I do need to call out, triplanar mapping for the diffuse is really easy, but it's a little trickier to get the lighting right. And that's because you need to construct your tangent properly. Ben Golis has a nice write-up that I'll include in the description that goes into depth, but it's pretty much just constructing the TBN matrices for each normal sample, and then doing the same tri-blending we were doing for the diffuse. Once we get that all going, you can see that everything kind of looks right from every angle. The second technique we'll talk about is texture splatting, and this is conceptually really simple. What you're basically doing is blending between multiple textures using some other source of data. Imagine here I've got 2 textures, so I've got this grass and I've got this stone texture, and I've got that landscape from before where all the middle will be stone. Imagine I go and create a third texture, just black and white, and then on the terrain I just blend between the grass or the rock, depending on whether the texture is black or white. This is, in essence, what texture splatting is. Now, since a texture can have 4 channels, RGBA, I could make my blend texture even more advanced by storing blending weights in each channel, and then my shader could blend between 4 different textures based on that. This is all pretty much what texture splatting is, blending between a bunch of different textures. And with that in mind, I'm going to race ahead to a much more flexible version that I've added here, complete with source code. What I do is, instead of having fixed textures in the shader, I bind just a single texture array. And what we'll do here is we'll load a whole bunch of textures. Here I've got 8 different textures that we'll mash together into a single texture array. And then, for each vertex, we'll pass down 4 pairs of values. Those will be the index of each texture and the weight. So as we generate each vertex on the terrain, we'll also decide what textures to apply. Here in this getTextureWeights function, I have a dictionary of all possible textures. And then I just apply weights depending on the height, moisture levels, whatever. We'll use this over here in the terrain chunk. So we'll generate the texture weight pairs, and then, this is important, so make sure you do this. You have to get the textures the same per face. And then we pass those down into the vertex shader. The vertex shader just passes those through to the fragment shader, and then here in the fragment shader we can loop over the 4 textures, sample them, add them all together, weighted by the weight values. Once we've done that, we've got textures all over the terrain, and we can use as many as we want on the terrain as long as you don't have more than 4 in one spot. Moving on, let's talk about how to effectively blend between textures on terrain. Now, normally, when you blend from one texture to another, you just use a simple alpha-based blending, so you get a super smooth transition from one side to the next. This is really easy to implement, but if you want to take this just a little bit further, you want to use what's called height-based blending. There's a great article by Andre Mishkinis that I'll link in the description, but the gist of the technique is that you incorporate height into the basic alpha blending calculation. The end result being that, let's say you're blending from grass to rocks, you get grass poking out between the rocks instead of a straight linear blend. Of course, to make it work with the texture splatting that we did above, we need to modify it, so I do that in terrain blend _4 to blend 4 samples simultaneously, since we need the result to be order independent. Now let's move on to the last technique here, a pseudo texture bombing technique. So first, let's talk about the problem being solved here. Looking at the landscape, we'll disable all the splatting and triplanar stuff, and here's a single texture applied over the whole landscape. Notice the distinctive pattern that appears, and it doesn't matter which texture we choose, the pattern will be there. It's really difficult to get rid of. And that's because if you look at the UVs, we've just tiled everything in every direction. It almost looks like a checkerboard. Now, texture bombing is a technique from NVIDIA from like 2004, and it's basically just a way of breaking up that repetition. They go a little nuts sampling the texture 4 times, but the results are good. Luckily, Inigo Quiles has another technique on his website, again linked below, that uses a clever trick that uses 8 virtually tiled versions of the texture and interpolates between 2 of them. So the shader code, honestly, I've just lifted this straight off Inigo's site since it worked out of the box, and you can see here as I enable it, the pattern is a lot less distinct. And there we have it, some techniques for texturing our procedural world. We can mix and match between the techniques too, so you can enable just 1 or 2. Here I've just got triplanar with a single texture, no splatting, and the texture repetition trick. This would look great as some sort of rocky world or moon, for example. The point here is to know and understand the techniques at your disposal. Source code is all available on GitHub, so fork it and go ahead and tweak it or add to it, do whatever you want. Make sure you hit like and subscribe, and I'll see you next time. Cheers.